Hello my dear students, in continuation of our question series from Neet examination paper, today our class is also based on PYQs of Neet paper that are from Neet 2022. Okay, today we will discuss some more questions from your class 11 curriculum. The first question of today's class is, if the initial tension of a stretched string is doubled. Okay, firstly what the data is given, initial tension and string is double. Okay, then the ratio of initial and final speed of the transverse wave. Okay, the question simply relate the tension and the speed. Okay, we should know the formula for tension and speed is V is proportional to tension. When there is a proportional relation, we can write initial speed upon final speed is equal to initial tension upon final tension under root. The question says tension doubles, so we can say the initial tension is T. After doubling it should be 2T. On solving we get 1 upon root T, that is root 2, that is our option number 2. Okay, this is simply the question based on the relation that the speed or the velocity is inversely directly proportional to root of the tension. Okay, moving to the next part, the question says a body of mass 16 gram experiences a gravitational force of 3 Newton. When placed at the particular point, the magnitude of gravitational field intensity at that point. We just have to calculate the magnitude of gravitational field intensity. So the relation is given by Ig is equal to F upon M, where F denote the force, that is equal to, according to question 3, and upon mass. Actually it is given in gram, we have to convert it into kg. So we get 60 into 10 raised to power minus 3, and after solving we get 50 Newton per kg. That are option number first. We simply calculate the value of gravitational field intensity by having the ratio of force upon mass. Okay, moving to the next question. The next question is the ratio of the distance traveled by the free falling body in first, second and third, fourth second is. We have to calculate the ratios of distance travel. Suppose we are provided with an object and this is our earth surface. This is our earth surface. Now, according to questions, the object is in freely falling conditions. When it is released from somewhere, it will freely fall toward the earth surface. We have to calculate the value of distance travel in first, second, third and fourth of second. Okay, in this type of case, we can simply say when the object is in freely fall condition, then we can take u initial velocity as equal to 0, and by using our fourth equation of motion, Sn is equal to u plus a by 2 2n minus 1, where nth denote the particular second. For first second we are taking n equal to 1, for second we are taking n equal to 2, and for third we are taking n equal to 3, and for fourth we are taking n equal to 4. And for all the 4 cases 1, 2, 3, 4, we can take u is equal to 0 because initially the object is at rest. Okay, so this is our main formula. Putting value of u equal to 0, we get a by 2 2n minus 1. Now A is what? A is actually acceleration, and when the object is in freely fall condition, then its acceleration is equal to acceleration due to gravity, which is same in all the second 1, 2, 3, 4. So we remove the same things, we get Sn is equal to 2n minus 1, because this question is about the ratio. When we have to calculate the ratios, the common thing always eliminates. That's why we remove u and a by 2. So the relation remains with the Sn is equal proportional to 2n minus 1. For first we put S1, for second we put S2, for third we put S3, and for fourth S4. And by putting the values and solving, we get ratio 1 is to 3 is to 5 is to 7. This is our required option number 2. This similar type of question has also been asked in the other NEET examination conducted in different years. Moving to the next question. The next question is an electric lift with a maximum load of 2000 kg, okay, including the weight of lift and the passengers, is moving up with a constant speed of 1.5 meter per second. The frictional force opposing the motion is 3000 Newton. What is the minimum power delivered by the motor to the lift in watt? We have to calculate the power. As we all know, the lift is moving upward. Okay, suppose this type of arrangement is there and we have a lift. This is kind of lift and this is moving upward. Okay, this is our lift. According to question, the weight of the lift including passenger is how much mass given? 2000 kg. Okay, what is value is 2000 kg. mass is equal to 2000 kg. Okay, now when the lift is moving up in upward direction, a opposite force, that is friction force, acting is 3000 Newton. Now we have to calculate the power, because this lift is operated by some motor. The lift is operated by some motor. We have to calculate the power delivered by the motor to push the lift in upward direction. Okay, we can solve this type of question. The lift is movement is having in opposite direction with the velocity. With velocity, how much velocity? 1.5 meter per second. So when the lift is moving upward, two forces are bringing it in downward direction. First is the friction force. Friction force is about 3000 Newton, and its own weight. How to calculate weight? We know weight is equal to W is equal to M into G. The value of M is how much? 2000 into G is 10. By just simply multiply 2000 into 10, we get 20,000 Newton. So this is frictional force and this is weight, that is 20,000 Newton. When the lift is moving in upward direction, two forces are trying to bring it downward direction. So what are those forces? That is equal to 20,000 plus 3,000, that is equal to 23,000 Newton. So this is the simply diagram of FBD, we can say free body diagram of the lift. Now simply the power is equal to force into velocity. How much force? 23,000 into velocity 1.5, we get 34,500 watt. That is our required option number B. Okay, this is our required option number 2. This is simply the application of concept of force. Force is equal to power is equal to force into velocity. Okay, moving to the next question. The next question says the volume occupied by the molecules contained in a 4.5 kg of water at STP, standard temperature and pressure, if the intermolecular forces vanishes away, we have to calculate the value of volume. Okay, volume occupied by how much mass? 4.5 kg if there is no intermolecular forces. So we can write the formula: volume is equal to number of moles, 22.4 liter. Number of moles can be written as mass upon molar mass, that is we have converted this type of liter into meter cube by just simply multiplying into 10 raised to power minus 3. Mass is given in question is 4.5 kg. 4.5 kg upon molar mass 18. By just solving we get the answer 5.6 meter cube. That is our option number 3. This is simply the application of basic concepts of this volume, STPs and relations. Moving to the next question. The area of rectangular field in meter square of length, we are provided with length 55.3 and breadth 25 meter after rounding off the value to current significant digit. This question is related to your significant figure concept. We have to calculate the area. Area of rectangle is given by length into breadth. By just multiplying we get 14 into 10 raised to power 2. So how we write this value? 1382.5 is rounded out to 1400 and 1400 can be written as 14 into 10 raised to power 2. So the resultant should have two significant figure, because in calculation of significant we ignore the exponent term, that's why we ignore the 10 raised to power 2. So after ignoring 10 raised to power 2, the remaining two terms 1 and 4 are the two significant figure. The answer is 14 into 10 raised to power 2. Okay, moving to the next part. The next question is related to the dimensional analysis. We have to relate the different formulas: gravitational constant, gravitational potential energy, gravitational potential and gravitational intensity. Just have to see in the table of the MLT dimensions. We get gravitational constant as m minus 1 L raised to power 3 T raised to power minus 2. Gravitational potential energy as m L square T raised to power minus 2. Gravitational potential as L square T raised to power minus 2. And gravitational intensity as L T raised to power minus 2. That is the required formula for acceleration also. Okay, this is the basic concept. That's why gravitational intensity is also known as acceleration. It shares the same dimension as the acceleration. Okay, moving to the next part. The question is related to simple pendulum. Okay, the question says there are two pendulums of length 121 cm and 100 cm start vibrating in a phase. At some instant, the two are at the mean position in the same phase, and the minimum number of vibration of the shorter pendulum, after which the two again are in the same phase position. We all know Pendulum is a simple arrangement of an object which is tied through a string through rigid support. This is known as its mean position, and when it moves to its extreme position. It moves to its extreme position. This is extreme position and this is extreme position. This is known as displacement and this is also known as displacement. Okay, and in opposite to displacement there is restoring force. This is restoring force which is always act in opposite direction to the displacement. Restoring force is simply denoted by F. Okay, now we just have to relate the length of the pendulum to its different vibrating phase. So the required relation is N TL is equal to N plus 1 TL, where TS denote the tension in the shorter and TL denote the tension in the longer. Okay, for longer we have putting the value of TL as 2 pi, because we know for simple pendulum time period is given by 2 pi root L upon G. So putting the same formula for shorter and longer, we get TL is equal to 2 pi root L. Length is actually 1.21 meter upon G, and for N plus 1 2 pi root L upon G, because for shorter the length is 100, that is equal to 1 meter. And solving we get N equal to 10. No, the N is the number of vibration of longer. If we have to calculate for shorter, then it is N equal to 1, we get 11. So the option is number 4. Okay, because we have used N variable for longer and N plus 1 for shorter. Okay, this simply shows as the length increases, the number of vibration, the number of oscillations and number of vibration has inverse relation, you can say. N for long length and for short that is N plus 1. For shorter it is N plus 1 and for longer it is equal to N. Okay, moving to the next question. The next question is related to assertion and reasons. We are provided with two statements. First statement is the stretching of a spring is determined by the shear modulus of the material of the spring. Okay, the reason is the coil spring of a copper has more tensile strength than the steel spring of the same dimension. In the light of the above two statements, choose the correct. We are provided with an assertion and we are provided with a reason. We just have to say whether the reason is actually applicable to assertion or not. So by just having the observation of option, we can say option number 2 is the correct. How it is correct? In the stretching of an spring shape, the shear changes, therefore the shear modulus is used. Okay, when we stretch a string, what changes? Its shape changes. That's why shear modulus is used. So because the Young modulus Y of steel is always greater than copper, so we can say A is true and reason is false. Okay, moving to the next question. The next question is related to projectile motion. A ball is projected with a velocity how much? 10 meter per second at an angle of 60 degree with vertical direction. Its speed at the highest point of its trajectory will be. You can see a ball is projected with initial velocity u, and this is our angle of projection. The question says it is projected with 60 degree with the vertical. Okay, 60 degree with the vertical direction. So we can calculate the angle with horizontal as 90 minus 60, that is equal to 30 degree. So this is 30 degree and this is 60 degree. Okay, because in question it is given 60 degree with the vertical direction, so the angle with the horizontal is equal to 60 degree, and we have to calculate the value of velocity at highest point. So velocity has only x component, so ux is equal to u cos theta. The value of u is equal to 10 and cos of 30 degree we get 5 root 3 meter per second. That is our option number first. Okay, this is simply the application of basic concept of projectile motion. Okay, this is all about the questions that have been asked in your NEET 22 question from class 11. In the upcoming series, we will discuss more previous year questions from a different examination, so that you can strengthen your knowledge and practice more and more questions, so that the chances of your selection get very stronger. Okay, thank you very much.